Chapter 5 Morphology of Flowering Plants. The wide range in the structure of higher plants will never fail to fascinate us. Even though the angiosperms show such a large diversity in external structure or morphology, they are all characterized by dozens of roots, stems, leaves, flowers, and fruits. In Chapter 20, we talked about classification of plants based on morphological and other characteristics. For any successful attempt at classification and at understanding any higher plant, or for that matter any living organisms, we need to know standard technical terms and standard definitions. We also need to know about the possible variation in different parts, count as adaptations of the plants with their environment, for example adaptation to areas habitats for protection, climbing, storage, etc. If you pull out any root, you will see that all of them have roots, stems and leaves. They may be bearing flowers and fruits. The underground parts of flowering plant is the root system, while the portion above the ground forms the shoot system. High point on the root. In majority of the dicotyledonous plants, the direct elongation of the radicle leads to the formation of primary root, which grows inside the cell, with pairs lateral roots of several orders that are referred to as secondary, tertiary, etc. roots. The primary root and its branches constitute the taproot system. As seen in the mustard plant, monocotyledonous plants, the primary root is short-lived and is replaced by a large number of roots. These roots originate from the base of the stem and constitute the fibrous root system. As seen in the wheat plant, in some plants like grasses, monstera, and the banyan tree, the roots arise from parts of the plant other than the radicle and are called adventitious roots. The main function of the root system are absorption of water and minerals from the soil, providing a proper anchorage to the plant part, storing reserve food material and synthesis of plant growth regulators. Figure 5.2 Different types of roots: taproot, fibrous, and adventitious. 5.1.1 Regions of the roots. The root is covered at the apex by a thimble-like structure called the root cap. It protects the tender apex of the root as it makes its way through the soil. A few millimeters above the root cap is region of meristematic activity. The cells of this region are very small, thin-walled, and with a dense cytoplasm. They divide repeatedly. The cells proximal to this region undergo rapid elongation and enlargement and are responsible for the growth of roots in length. This region is called region of elongation. The cells of the elongation zone gradually differentiate and mature. Hence, this zone proximal to the region of elongation is called region of maturation. For this reason, some of the epidermal cells form very fine. From this region, some of the epidermal cells form very fine and delicate thread-like structures called root hairs. These root hairs absorb water and minerals from the soil. 5.2 The stem. What are the features that distinguish a stem from a root? The stem is the ascending part of the axis bearing branches, leaves, flowers, and fruits. It develops from the plumule of the embryo of a germinating seed. The stem bears nodes and internodes. The region of the stem where leaves are born are called nodes, while internodes are the portions containing two nodes. The stem bears buds which may be terminal or axillary. The stem is generally green when young and later often become woody and dark brown. If main function of the stem is spreading out branches bearing leaves, flowers, and fruits, it conducts water, minerals, and photosynthesis. Some stems perform the function of storage of food, support, protection, and vegetative propagation. 5.3 The leaf. Leaf is a lateral, generally flattened structure borne on the stem. It develops at the node and bears a bud in its axillary. The axillary bud later develops into a branch. Leaves originate from shoot apical stems and are arranged in an epiphytal order. They are the most important vegetative organs for photosynthesis. A typical leaf consists of three main parts: a leaf base, petiole, and lamina. The leaf is attached to the stem by the leaf base and may bear two lateral small leaf-like structures called stipules. In monocotyledons, the leaf base expands into the sheath, covering the stem partially or fully. In some leguminous plants, the leaf base may become swollen, which is called parotinase. The petiole help hold the blade to light. Long, thin, flexible petioles allow leaf blade to flutter in the wind, thereby cooling the leaf and bringing fresh air to leaf surface. The lamina or the leaf blade is the green expanded part of the leaf with veins and veinlets. There is usually a middle prominent vein which is known as midrib. Veins provide rigidity to the leaf blade and act as channels of transport for water, mineral and food material. The shape, margin, apex, surface and extent of incision of lamina varies in different leaves. 5.3.1 Venation. The arrangement of veins and the veinlets in the lamina of the leaf is termed as venation. When the veinlets form a network, the venation is termed as reticulate. When the veins run parallel to each other within a lamina, the venation is termed as parallel. Leaves of dicotyledonous plants generally possess reticulate venation, while parallel venation is the characteristic of most monocotyledon. 5.3.2 Types of leaves. A leaf is said to be simple when its lamina is entire or when incised, the incision do not touch the midrib. When the incision of the lamina reach up to the midrib, breaking into a number of leaflets, the leaf is called compound. A bud is present in the axial of petiole in both simple and compound leaves, but not in the axial of leaflets of the compound leaf. The compound leaves may be of two types. In a pinnately compound leaf is number of leaflets are present on a common axis, the rachis, which represents the midrib of the leaf, as in neem. In palmately compound leaves, the leaflets are attached at the common point, that is, at the tip of petiole, as in silk, cotton. 5.3.3 Phyllotaxy. Phyllotaxy is the pattern of arrangement of leaves on the stem or branch. This is usually of three types: alternate, opposite, and whole. In alternate type of phyllotaxy, a single leaf arises at each node in alternate manner, as in cineros, mustard, and sunflower plants. In opposite type, a pair of leaves arise at each node and lie opposite to each other, as in calotropis and guava plants. If more than two leaves arise at a node and form a whole, it is called whorled, as in Estonia. Figure 5.6 Different types of phyllotaxy: alternate, opposite, whorled. 5.4 The inflorescence. A flower is a modified shoot wherein a shoot apical meristem changes to floral meristem. Internode do not elongate and axis gets condensed. The apex produces different kinds of floral appendages laterally at successive nodes instead of leaves. When a shoot tip transforms into a flower, it is always solitary. The arrangement of flowers on the floral axis is termed as inflorescence. Depending on whether the apex gets developed into flower or continues to grow, two major types of inflorescence are defined: racemose and cymose. In racemose type of inflorescence, the main axis continue to grow. The flowers are borne laterally in an equipetal succession. In cymose type of inflorescence, the main axis terminates in a flower and is limited in growth. The flowers are borne in a basipetal order. 5.5 The flower. The flower is the reproductive unit in the angiosperms. It is meant for sexual reproduction. A typical flower has four different kinds of holes arranged successively on the solen end of the stalk or pedicel, called thalamus or receptacle. These are calyx, corolla, androecium, and gynoecium. Calyx and corolla are accessory organs, while androecium and gynoecium are reproductive organs. In some flowers like lily, the calyx and corolla are not distinct and are termed as variant. When a flower has both androecium and gynoecium, it is bisexual. A flower having either only stamen or only carpel is unisexual. In symmetry, the flower may be actinomorphic, radial symmetry, or zygomorphic. bilateral symmetry. Coniflower can be divided into two equal radial halves in any radial plane passing through its center. It is said to be actinomorphic. Mustard theoretically, when it can be divided into two similar halves only in one plane, particularly only in one particular vertical plane, it is zygomorphic. For example, P. Primomor bin cassia. A flower is asymmetric, irregular if it cannot be divided into two similar halves by any vertical plane passing through the center. As in Kanna, a flower may be triangular or pentagonal when the floral appendages are in multiple 3, 4, or 5 respectively. Flowers with dates, that is the leaf on the base of the pedicel, are called bracteate, and those without rings, bracteate. Figure 5.9. Figure 5.9. Position of floral buds on thalamus. Hypogynous, perigynous, and epigynous. Based on position of calyx, corolla, and endometrium in respect of the ovary on thalamus, the flowers are described as hypogynous, perigynous, and epigynous. In the hypogynous flower, the gynoecium occupies the highest position while the other parts are situated below it. The ovary in such flower is said to be superior, for example, mustard, sinners, and brinjal. If gynoecium is situated in the center and other parts of the flower are located on the rim of the thalamus almost at the same level, it is called perigynous. The ovary here is said to be half inferior, for example, blunt beech rose. In epigynous flowers, the margin of thalamus grows upward, enclosing the ovary completely and getting fused with it. The other parts of flower arise above the ovary, hence the ovary is said to be inferior, as in flowers of guava and cucumber, and the ray florets of sunflowers. 5.5.1 Parts of flower. Each flower normally has 4 floral poles, for example, calyx, corolla, and raceme, and gynoecium. 5.5.1 Calyx. The calyx is the outermost pole of the flower, and the members are called sepals. Generally, sepals are green, leaf-like, and protect the flower in the bud stage. The calyx may be gamosepalous, sepals united, or polysepalous, sepals free. 5.1.2 Corolla. 5.1.2 Corolla. Corolla is composed of petals. Petals are usually brightly colored to attract insects for pollination. Like calyx, corolla may also be gamopetalous, that is, petals united, or polypetalous, petals free. The shape and color of corolla vary between plants. Corolla may be tubular, bell-shaped, funnel-shaped, or quill-shaped. Distribution, the mode of arrangement of sepals of petals and floral bud with respect to the other members of the same whole is known as distribution. The main types of distribution are bulbate, twisted, and brigade, and vexillary. When sepals or petals in a whole just touch on another at the margin without overlapping, as in calotopes, it is said to be violet. If on margin of appendage overlap that of the names and also on as in Sanerois, in the end bottom, it is called twisted. The margins of sepal or petal overlap another but not in any particular direction, as in cassia and more. The distribution is called imbricate. In pea and bean flowers, there are 5 sepal, there are 5 petals. The largest standard overlap the 2 lateral petals, whereas which in turn overlap with 2 smallest anterior petals. This type of distribution is known as vexillary or papilionaceous. 5.5.1.3 Raceme is composed of stamens. Each stamen, which represents the male reproductive organ, consists of a stalk or a filament and an anther. Each anther is usually bilobular, and each lobe has 2 bars and the pollen sac. The pollen grains are produced in pollen sac. A sterile stamen is called stamener. Stamens of the flower may be united with other members such as petals or among themselves. When stamens are attached to the petals, they are epipetalous as in brinjal, or epiphyllous when attached to the perianth as in flowers of lily. Stamens in a flower may either permanently, that is polyandrous, or may be united in varying lambics. The stamens may be united into on bands or on bundles, called monoadelphous as in China rose, or two bundle diadelphous as in pea, or into more than two bundles polyadelphous as in citrus. There may be variation in the length of filament within a flower as in salvia and mustard. 5.5.1.4 Gynoecium. Gynoecium is the female reproductive part of flower and is made up of one or more carpels. A carpel consists of three parts, namely stigma, style, and ovary. Ovary is the enlarged basal part on which lies the elongated tube, the style. The style connects the ovary to the stigma. Stigma is usually at the tip of the style and is the receptive surface for pollen grains. Each ovary bears one or more ovules attached to a flattened cushion-like placenta. When more than one carpel is present, they may be free as in lotus and rose and are called apocarpus. They are apparent carpels, polycarpels are fused as in mustard and tomato. After fertilization, the ovules develop into seeds and the ovary mature into a fruit. Placentation. The arrangement of ovules within the ovary is known as placentation. The placentation are of different types, namely marginal, axial, parietal, basal, central, and precentral. In marginal placentation, the placenta forms a ridge along the ventral surface of the ovary, and the ovules are borne on this ridge, forming two rows, as in pea. When the placenta is axial and the ovules are attached to it in a multilocular ovary, the placenta is said to be axial, as in China rose, Finland. In parietal placentation, the ovules develop in inner wall of ovary or peripheral part. Ovary is unchambered, but it becomes two-chambered due to the formation of the full septum. For example, mustard and ecdymon. When the ovules are borne on central axis and septum absent, as in the dances and primrose of the placentation, is called precentral. In basal placentation, the placenta develops at the base of ovary and a single ovum is attached to it, as in sunflower, marigold. 5.6 The fruit. The fruit is a characteristic feature of the flowering plants. It is a mature or ripened ovary developed after fertilization. If a fruit is formed without fertilization of the ovary, it is called a parthenocarpic fruit. Generally, the fruit consists of a whorl or pericarp and seeds. The pericarp may be dry or fleshy. When pericarp is thick and fleshy, it is differentiated into the outer epicarp and the middle mesocarp and the inner endocarp. In mango and coconut, the fruit is known as drupe. They develop from monocarpillary superior ovaries and are unseeded. In mango, the pericarp is well differentiated into an outer thin epicarp, a middle fleshy mesocarp, and an inner stony hard endocarp. In coconut, which is also a drupe, the mesocarp is fibrous. 5.7 The seed. The ovules after fertilization develop into seeds. A seed is made up of a seed coat and an embryo. The embryo is made up of a radicle and embryonal axis and on, as in with maize, or two cotyledons, as in gram and pea. 5.7.1 Structure of a dicotyledonous seed. The outermost covering of a seed is the seed coat. The seed coat has two layers, the outer distal and the inner tegmen. The hilum is a scar on the seed coat through which the developing seeds were attached to the fruit. Above the hilum is a small pore called the hacopyle. Within the seed coat is the embryo, consisting of an embryonal axis and two cotyledons. The cotyledons are often fleshy and full of reserve fruit materials. At the two ends of the embryonal axis are present the radicle and plumule. In some seeds, such as castor, the endosperm formed as a result of double fertilization is a fruit storing tissue and called endospermic seeds. In plants such as bean, gram, and pea, the endosperm is not present in mature seeds and Such seeds are called non-endosperms. 5.7.2 The structure of monocotyledonous seed. Generally, monocotyledonous seeds are endospermic, but some, as in orchids, are non-endospermic. In seeds of cereals, such as maize, seed coat is membranous and generally fused with the fruit wall. The endosperm is bulky and stores food. The outer covering of endosperm separates the embryo by a proteinous layer called aleuron layer. Then embryo is small and situated in a groove at one end of the endosperm. It consists of one large and shield-shaped cotyledon known as scutellum and a short axis with a plumule and a radicle. The plumule and radicle are enclosed in shades which are called colloidal and coleorace respectively. 5.5 Semi-technical description of a typical flowering plant. Various morphological features are used to describe a flowering plant. The description has to be brief in a simple and scientific language and presented in a proper sequence. The plant is described with its habitat with equipped root system and leaves, and then floral characters, inflorescence, and flower parts. After describing various parts of plant, a floral diagram and a floral formula are presented. The floral formula is represented by some symbols. In floral formula, BR stands for bracteate, K stands for calyx, C for corolla, P for perianth, A for androecium, and G for gynoecium. G underscore for superior ovary and G uppercase for inferior ovary. Fusion is indicated by enclosing the figure within bracket and adhesion by a line drawn above the symbols of the floral parts. The floral diagram provides information about the number of parts of a flower, their arrangement and relation they have with one another. The position of another axis with respect to the flower is represented by a dicot on the top of the floral diagram. Calyx, corolla, and gynoecium are drawn in successive folds, calyx being outermost and the gynoecium being in center. Floral formula also shows position and adhesion within parts of folds and between the folds. The floral diagram and floral formula in figure 5.16 represents the mustard plant family Brassicaceae. 5.9 Solanaceae. It is a large family commonly called as the potato family. It is widely distributed in tropics, subtropics, and even temperate zones. Vegetative characters: plants mostly herbs, shrubs, and rarely small trees. Stem herbaceous, rarely woody, aerial, erect, cylindrical, branched, solid or hollow, hairy or glabrous. Underground stem in potato, Solanum tuberosa. Leaves alternate, simple, rarely pinnately compound, X stipulate, venation, reticulate. Floral characters: inflorescence solitary, axial or cymose as in Solanum. Flower bisexual, actinomorphic. Calyx sepals 5, united, persistent, valve distribution. Corolla petals 5, united, valve distribution. Androecium stamen 5, epipetalous, androecium, gynoecium. Bicarpellary, obligately placed, syncarpous ovary, superior fruit. Gynoecium bicarpellary, obligately placed, syncarpous ovary, superior, bilocular, placenta swollen with many ovules, axial, fruits, berry or capsule, seeds many endospermous. Economic importance: Many plants belonging to this family are source of food: tomato, brinjal, potato, spice, chili, medicine, belladonna, ashwagandha, fumigatory tobacco, ornamentals, petunia. Summary: flowering plants exhibit enormous variation in shape, size, structure, mode of nutrition, lifespan, habit, and habitat. They have well-developed root and shoot system. Root system is either taproot or fibrous. Generally, the ecotyledonous plants have taproot, while monocotyledonous plants have fibrous roots. The roots in some plants get modified for storage of food, mechanical support, and respiration. The shoot system is differentiated into stem, leaves, flowers, and fruits. Morphological features of stems like presence of mouth and internodes, multicellular hair, and positively phototropic nature help to differentiate the stem from the roots. Leaf is a lateral outgrowth of stem developed exogenously at the node. These are green in color to form the function of photosynthesis. Leaves exhibit marked variation in their shape, size, margin, apex, and extent of incisions of leaf blade lamina. The flower is a modified shoot meant for sexual reproduction. The flowers are arranged in different types of inflorescence. They exhibit enormous variation in structure, symmetry, position of ovary in relation to other parts, arrangement of petals, sepals, ovules, etc. After fertilization, the ovary is modified into fruits and the ovules into seeds. Seeds either may be monocotyledonous or dicotyledonous. They vary in shape, size, and period of viability. The floral characteristics form the basis of classification and identification of flowering plants. This can be illustrated through semi-technical description of families, and a flowering plant is described in a definite sequence by using scientific terms. The floral features are represented in the summarized form as floral diagram and floral formula. Chapter completed. Thanks.